Hello everyone, welcome back. In our previous session, we are having successfully completed our base tool interface setup. Now we will be working on our calculator tool implementation with a strong focus on security. Today we will be implementing safe code execution with a T. First, we need to be understanding why using eval is being extremely dangerous. It is allowing arbitrary code execution, which can be a major security vulnerability. Instead, we will be using abstract syntax tree parsing, which is providing a secure alternative for executing mathematical expressions. Having this security first mindset is being essential for building trustworthy AI systems that can be safely deployed in production environments. Then we will be implementing our mathematical operations whitelist. We will be creating a whitelist of safe mathematical operations, specifically add, sub, mul, div, and po operations. Our system will be rejecting any operations that are not on this approved list, ensuring that only safe mathematical computations are being allowed. This is demonstrating safe code execution patterns that we can be using in production environments. This calculator tool is going to be our first practical example of how to build secure tools that our agent can be using safely without exposing our system to potential security risks. So let's be getting started with building this secure calculator tool that will be serving as a model for security conscious tool development. Now let me be opening our calculator.py file and starting to write the code for our secure calculator tool. First, I'm importing the required modules. So I'm importing AST. This is giving us access to abstract syntax tree functionality for safe code parsing. Then I am importing operator. This is providing us with safe mathematical operator functions. Next, I am importing dict and any from typing for our type hints. Finally, I am importing our base tool and tool result from our base.tool module. Now I am creating our calculator tool class that is inheriting from base tool. I am writing the init method. I am calling super init with name calculator and description perform mathematical calculations and solve math problems. Now I am creating our safe operators dictionary. This is the heart of our security implementation. I am mapping AST node types to safe operator functions. So I am mapping addition operations using the add node to the addition function, subtraction operations using the sub node to the subtraction function, multiplication operations using the mult node to the multiplication function, division operations using the div node to the true division function, power operations using the POW node to the power function, and unary subtraction using the usub node to the negation function. This whitelist is ensuring that only safe mathematical operations are being allowed. Next, I am implementing the getAtSchema method. This method is returning a JSON schema that is describing our tool's parameters. I am defining that we are expecting an expression parameter of type string with a description explaining what kind of mathematical expressions are supported. Now I am creating the evaluate method. This is where our secure AST parsing is happening. This method is taking an AST node and safely evaluating it. I am checking if the node is a constant for Python 3.8 plus or a num for older Python versions. In both cases, I am returning the numeric value. If it's a bin of binary operation, I am recursively evaluating the left and right operands. Then I am applying the corresponding operator from our safe operators dictionary. If it's a unary operation, I am evaluating the operand and applying the unary operator. If it's any other type of node, I am raising a type error because it's not on our whitelist of safe operations. Finally, I am implementing the execute method. This method is taking an expression string and returning a tool result. I am wrapping everything in try-catch blocks for proper error handling. First, I am cleaning the expression by stripping whitespace. Then I am passing the expression using as to pass with mode equal to v1, and I am evaluating it using our save and evaluate method. I am formatting the result nicely. If it's a float that represents an integer, I am converting it int. Otherwise, I am rounding it to 10 decimal places. If everything is successful, I am returning a tool result with success equal to true and detailed data, including the original expression, result, formatted result, and result type. I am handling specific exceptions, zero division error for division by zero, syntax error and value error for invalid expressions, type error for unsupported operations, and a general exception handler for any other errors. Its implementation is ensuring that our calculator tool is completely secure and can only perform safe mathematical operations. We are now being done with our calculator tool implementation. We are having successfully created a secure calculator that is using AST parsing instead of dangerous eval function. Our tool is implementing a whitelist of safe mathematical operations and is properly handling all types of errors like division by zero, syntax errors, and unsupported operations. Calculator tool is demonstrating how we can be building secure tools that our agent can be using safely without exposing our system to security vulnerabilities. In the next session, we will be working on our web search tool implementation. We will be working on HTTP request implementation. This is extending our agent's knowledge beyond its training data cutoff by allowing it to search for current information on the internet. We will be implementing HTTP request handling with proper error management, and we will be setting up network timeout and retry strategies for reliability. Then we will be working on API integration and authentication. We will be implementing API authentication and secure credential handling so our tool can be accessing search services securely. We will also be processing the responses into formats that our agent can be understanding easily. This is connecting our agents to the broader digital world and giving them access to current information. This web search tool is going to be crucial for making our personal assistant truly powerful, as it will be able to search for real-time information and stay current with the latest developments. So see you in the next session where we will be building this important web search capability